Hi guys. So now in this video, I will solve a few examples about the forms 0 over a number and a number over 0. So firstly, in algebra, if you have a case like 0 over a number, let's say 5, it is equal to 0. If you have something like 5 over 0, it is undefined. But when you have the second case with limits, so after you replace the number instead of x, if you have a case like 5 over 0, that means you will get a result some for this kind of expressions with limits, which is it's going to be related with infinite. The result should be infinite. You just need to check for will it be plus infinite or minus infinite, positive or negative infinite. So now let's start with this first question. As I have taught in every limit question, firstly we should check that what happens when you replace 5 instead of x. It will become 3 times 5 squared minus 16 times 5 plus 5 over 5 squared plus 8 times 5 plus 15. 5 squared is 75, 5 squared is 25, times 3 is 75, plus 5 more is 80, minus 16 times 5 is 80, over 5 squared is 25, plus 15, 25, 30, 40, it will be 40, and plus 8 times 5 will be 40 also. So here we will have 0 over 80, which is this limit is equal to 0. There is no need to make any more calculations. So now the second example. Let's replace the number 1 in here. 1 cube minus 6 times 1 squared plus 9 times 1 plus 4 over 1 squared minus 4 times of 1 plus 3. Let's calculate in here. 1 cube is 1 minus 6 plus 9 plus 4. So 1 squared is 1 minus 4 plus 3. The final case, 9 plus 4 is 13 plus 1, 14. 14 minus 6 is 5. 1 plus 3 is 4. 4 minus 4 is 0. So right now we should have a result infinite. But should it be plus infinite or minus infinite? So we should check that. What if limit of this one, x approaches 1 from left for the same function if you search for it? So if you put some smaller values, smaller than 1, something like 0.9, up there you will have something smaller than 5, which is a positive result. So if you put some smaller values, some numbers smaller than 1, what kind of result will be there? Let's say if you put 0 in here, there's going to be a positive result. If you put 1.5 or 1 over 2, 1 over 2 squared is 1 over 4, minus 2, 4 times 1 over 2 is 2, and plus 3. So 3 minus 2 is plus 1, plus 1 plus 1, so positive result in here. So it's going to be plus infinite. If you do the checking from right side, when x approaches 1 from right side, what happens then? For the same function. So let's delete this calculating part. So since the results are in here for the numerator part, they will be around 5, like kind of you can get 4, or if it is bigger than 1 you can get something like 6. So doesn't matter which way it's going to be. So it's going to be plus. So the problem is the denominator. So we should do the checking for denominator. If I put something bigger than 1, like 1.1, or let's say 2, approaching 1 from right side, you can say 2 also as well. So what happens? 2 squared is 4, 2 times 4 is 8. So 4 plus 3 is 7, 7 minus 8 is minus 1, so negative result. What if we try 1.1? Let's do that. It's going to be minus 4.4. 1.1, which is 11 squared, is 121. Sorry, 121. So we can make it 1.21. So plus 3 going to be 4.21 minus 4.40. It's going to be a negative result. So plus over minus is going to be minus infinity. Since these are different, there is no result for this one. There is no result. Sometimes when you do this checking from right and left, you get plus infinite from first, plus infinite from second, so you can say that the final result is plus infinite. Or sometimes when you do this checking from right and left, you get minus infinite over there, minus infinite over in here, so you can say that yes, there is a result minus infinite. But right now, since they are different from left and right, you say that for this example, there is no result. The next example, the third one. Let's replace the number 2 like we do always. 2 squared minus 3 times 2 plus 2 over 3 times of 2 squared plus 2 minus 14. So 2 squared is 4 minus 6 plus 2. 2 squared is 4 times 3 is 12 plus 2 minus 4. So it's going to be 0 over 4 plus 6, 4 plus 2 is 6, minus 6, 0. 12 plus 2, 14, 0 over 10 is equal to 0. The result of this limit is equal to 0. There is no need to make any more calculations. So now the fourth example. Let's replace the number 3. 4 times 3 cubed minus 23 times 3 squared plus 30 times 3 minus 9 over minus 2 times 3 squared plus 7 times 3 minus 3. So this is going to be 3 cube is 27. 4 times of 27 is 108. Minus 3 squared is 9. 9 times 23 is 10 times 23 is 230 minus 23. 230 minus 20 is 210 minus 3 more 207 and plus 90 minus 9 over 3 squared is 9, 2 times 9 is minus 18 plus 21 minus 3. So then we can easily calculate for the denominator that it's gonna be 0. For the numerator part, how can we make it easier? So minus 207 plus 108 will be minus 99. If you add 99 to this one, it's going to be minus 99. I have over there minus 99, minus 9 more, minus 108. It will be minus 99 plus minus 9 more, or minus 99 plus 90 is minus 9, minus 9 and minus 9 will be minus 18. So we have number over 0, the 4. So we should do the checking from left and right. Then if we get same result for the left and right, uh, for the left and right side, what if the x numbers approaches 3 from left side for the same function? What if x numbers approaches 3 from right side for the same function? I think they are going to be different since this is not like complete square. That's why it's going to be, I mean, I mean, for one side is going to give us negative result, for the other side is going to be positive result. So there is only one case. If the denominator is complete square, I mean, all of them with parentheses and power 2, if it can be written like that, so both of them will give us negative infinite, then it will be negative infinite, the final result. But right now, let's do the checking. Approaching 3 from left side, I mean, the results will be around minus 18, so there will be a negative result in here. Let's check for the denominator part what will happen. If I put some smaller value, smaller than 3 in here, some numbers smaller than 3, let's say minus 2, let's positive 2, sorry, smaller than 3, positive 2, let's check that one. 2 squared is 4, minus 2 times 4 is minus 8, plus 2 times 4, 2 times 7 is 14, minus 3. So what kind of result will it be? Minus 8 minus 3 is minus 11, and plus 3. What if I put a number bigger than 3, like 4? 4 squared is 16, minus 2 times 16 is minus 32, 4 times 7 is 28, minus 3, minus 32, minus 3 is going to be minus 35, plus 27, minus 35 plus 10, 27 is minus 7. Minus 35 plus 27 is minus 7. So when you put a number smaller than 3, you will get positive results. So the final limit will be equal to minus infinite. So I am doing this research because when I have number over infinite, it will be related to with infinite, and I should check that should it be plus infinite or negative infinite. To be able to write a final result in here, both checkings should give me the same signed infinite. So now the second part checking, the numerator part will be again around minus 18, which is negative result. It can be minus 16, minus 17, or minus 19, doesn't matter. So negative results around 3. What about the denominator that I have made checking with 4? When it approaches 3 from right side, so it's going to be negative results. So minus over minus is plus infinite. Since they are different, no limit. So no result for this example. If they were asking us check only from left side, we could write it's going to be minus infinite. Check only from right side, from here, we could write is plus infinite. Or if we would have found the same signed infinites in these two places, we could write it over there as the result, like minus infinite in here, minus infinite over there. If they were both minus infinite, we could write that the final result is minus infinite. Thank you for listening.